morning. Let's try again. You had a good breakfast, right? Good morning.
Good morning.
Very good. Okay. So anybody in the room not for the Java EE 7 session? Just making sure. Oh, you're not for the session?
Oh no, I thought there was another one. I didn't go.
No, this is for the Java EE 7 and the HTML5 session. Just making sure. Okay. Thank you. Thank you very much. I know you have a choice of attending many sessions. I'm glad you came to this. Thank you very much for that. My name is Arun Gupta, and this is a slide-free session. There are no slides in this session. For the next 3 hours, I'm going to be introducing you several features of Java EE 7 using only code. I have a whole bunch of samples. We'll talk about different technologies. We did a hands-on lab yesterday, but that was primarily showing you how stuff can be done, and then you were doing by your own. Today, I'm going to be showing you a whole bunch of samples, introducing different technologies. But before we dig into the samples, Java EE 7 is the latest release of the platform. In the sense, it literally got released last month. How many folks use Java EE in their daily life today? Okay, pretty much all of you. Okay, how many use Java EE 6? Okay, most of you. Very cool. So I think this will be very valuable to you. And for the folks who don't know it, specifically for the folks who left J2EE, I'm saying J2EE 1.4 because of some other proprietary frameworks. This will be a good eye-opener in the sense what new features are coming as part of Java EE 7. Now, Java EE 7, the key focus over there was improving the productivity, meeting enterprise demands, and embracing HTML5. To that extent, we have added 4 new specifications to the platform. So first of all, there is a brand new way of building WebSocket-driven applications. I'm going to show you some samples around that. Some pre-built samples. I'm not going to do any live coding, but the samples are all pre-built so that we can walk through them, but I'll explain them in detail. There is a brand new API to do JSON processing and generation as well, part of the platform itself. So you don't have to bundle any third-party APIs. We have also added support for concurrency utilities. Now, if you're building a Java EE application, the typical, you're not allowed to create your own threads. The idea is Java EE is a managed environment. Now, in a managed environment, if you create unmanaged threads, how do I pass class loading context, security context, GIND context, all of those? With concurrency utilities, we can actually create managed threads where all that context is allowed and passed to the thread. And then finally, we added support for batch processing. A lot of this work actually came from the Spring Batch. So if you guys are using Spring Batch, this will look very familiar. And for the first time in the history of Java EE, Spring, or actually VMware, contributed to the JCP community, and worked very actively in the JSR 352 group. So once again, WebSocket, JSON, batch, concurrency. Those are the 4 brand new specifications. And in addition to that, JAX-RS 2, which is a Java API for RESTful web services, JMS, got a major relift. So both of these specifications got a big uplift. And there were a bunch of other improvements in several specifications. So my goal would be kind of take these technologies one at a time, show you some sample applications around that. Point samples, hello world kind of a samples, but at least you will get an idea of what these technologies are about and what they're going to do. I can start, well, I'm recording here.
You could have your report on
Okay.
here. So we do this. You pick yourself for this day,
That is me.
and then you just hit that.
I hit that. All right. All right, so let's get started. Can you guys hear me at the back of the room? Okay. Hopefully my voice will hold that long. So what I have here is NetBeans IDE 731. I'm going to bump up my font. Oh, 18 is good. Okay. The first technology that I'm going to focus on is WebSocket. Now, what is the purpose of WebSocket? If you think about HTTP, every request that you make from a client to a server, and then the response comes back to you. Now every request that you make goes over a TCP connection. There is a keep alive, but applications cannot rely upon them. So think about every request is initiating a new TCP connection. And with every request, you are sending a choke full of headers and getting them back in a response as well. Those are all required by HTTP protocol. There are at least a minimum set of headers that need to be sent, but typically if you're sending a request from browser, whole bunch of headers are going back and forth. That's where WebSockets come to our rescue. Now WebSockets, they leverage the HTTP connection. In HTTP protocol, it defines there is a mechanism of upgrading the protocol. That was primarily defined for upgrading from an older version to a newer version and things like that. WebSocket leverages that upgrade mechanism, and then it says, I'm going to upgrade from HTTP to a WebSocket protocol. Now, once the protocol is upgraded, all the communication between the client and the server, I mean, effectively it's a client and server to begin with, but essentially they are peers. But once the client and server are connected using a WebSocket, all the communication between them is over a single TCP connection. And the connection is bidirectional in the sense client can send to a server, server can send to a client. It's not like HTTP where client is sending a request and server is sending a response back. There are no predefined message exchange patterns. Client can send as many requests, server can send as many requests as well. The request response coordination needs to be done at the WebSocket layer. So it's full duplex, bidirectional communication channel over a single TCP connection. Those are sort of my three keywords which really highlights the benefit of WebSocket. Okay, so let's take a simple example. Now, what did we do to enable WebSocket-driven applications in Java EE7 platform? JSR 356. JSR stands for Java Specification Request. Now, that's the way we build standards as part of the Java platform. So JSR 356 is one of the JSRs for the Java EE7 platform, where we define how a standard API for building WebSocket applications is going to be built. So let's take a look. I'm going to start with a very simple canonical chat sample. Okay.
Do you have these code samples available?
I will make them available. I'm doing the entire recording as a Camtasia as well. I'll push it out all live as a YouTube recording. Yeah. So you will have access to the entire recording and the corresponding code samples. Now, as of date, the only Java EE7 compliant application server is GlassFish, which is also the reference implementation of Java EE. So that's the only container that you can use today. Now, JBoss has announced plans to be Java EE7 compliant. WebLogic, WebSphere, they're all going to follow as well. But today, yes, the only compliant option is Java GlassFish, basically. And so in order to run these samples, I'm deploying them on GlassFish. Now, all of these samples, they do not have, once again, they do not have anything GlassFish specific. They are pure Java EE samples. So if you deploy them on any Java EE7 compliant container, they should just run fine. So let me run this sample. I'm going to run it on GlassFish Server 4.0. Now this is NetBeans IDE. I think it's the best IDE for doing Java EE development. Each IDE has their own strong points. NetBeans really provides a very good comprehensive support for Java EE development. I'll highlight some tools, wizards, templates that are available that makes your life easy here. One of them being, like, if you go to services here, you can configure multiple servers over here. So you can click on servers, say add server. You can configure Tomcat, GlassFish, JBoss, WebLogic, all of those servers very easily. So for example, in my case, I've configured it to run it on GlassFish. Okay, so that's my simple chat interface. I'm sort of a graphically challenged. I'm more a server-side guy, but that's how my chat sample looks like. But let's say I copy it and open up my Firefox as well. Okay. So here is my chat sample in Firefox, and this is my Chrome. So now if I say Duke join, so I click on join here, it says received message Duke join, and the list is populated in my other browser as well. Now if I go here and I say Duke 2 join, the list gets updated and accordingly gets updated in my other browser as well. Now I can say from this browser, for example, I want to chat now. So it gives me the user which has given the message, and same thing here. I could say howdy, and the message gets reflected. Okay, so very simple, very trivial, but let's look at the code behind this, what made this possible. So, question. Say again? Oh, okay. Bump up the font a little bit higher. Okay, I can do that. Better? Okay. Well, I was hoping my code could show up on one screen. Let me try to fit it in one screen now. There you go. It still fits in one screen. That's good. So this is all the code that is required on the server side to make it happen. Literally, this is just one class, one Pojo that is all doing my chat backend effectively. Now, if you take a look at the source code, line 61 is first of all, 57 is my public class chat endpoint. How do I make this as a server endpoint or a WebSocket server endpoint? I just add the annotation add server endpoint. Then I give it the URI or URL where the WebSocket is going to listen. So I provide the URL as the value parameter. Then on line 61 and 66, I have my two methods, say on open and on close. Those are my lifecycle callbacks. So whenever somebody tries to connect or a client tries to connect to my endpoint, call this method, and I put at on open annotation. Similarly, at on close annotation saying, oh, somebody's trying to close the connection, so call this method. Effectively, in those methods, all I'm doing is I am the parameter, first of all. The parameter is the encapsulation of the other end of the connection. So the client that is trying to connect or the session that is trying to establish a WebSocket session over here. So it kind of gives me all the details about the other remote endpoint. So all I'm doing is in this on open and on close, maintaining a list of clients that are connected at a given point of time, and which is there in my private static final set of session. So at any given point of time, I have the list of clients that are connected. Then in my on message method, which is 71, I have at on message. Now WebSocket endpoints can send text data or a binary data. So now on the server endpoint, you need to have corresponding methods that can receive a text data or a binary data. In this case, I'm saying string. The moment I put the string parameter, it understands that there's a text message coming in, and it's going to be dispatched to this particular method. And I'll explain more, how the method dispatching works. But for now, think about the string parameter, and this is the text message. The payload gets mapped to the string message parameter. The session over here is the encapsulation again of the other end of the connection. And again, the session is an optional parameter in this case. But effectively, if I want to send or broadcast a message to all the clients, I just iterate over all the peers and I send a message. So that's my simple server side endpoint here. Now let's take a look at my corresponding client side. The JSP itself is pretty simple. I just have form with no action here, with a text area, couple of methods here, couple of buttons here, join and send message. The bulk of the action really happens in my JavaScript, which is my WebSocket.js. I could call it whatever I want, but just for convenience, I call it WebSocket.js. So if I go here, now the way you connect to a HTTP endpoint is using HTTP URI scheme. WebSocket protocol introduces a new URI scheme called as WS:. So if you are connecting to a WebSocket endpoint, you have to connect using WS://. So here I'm just dynamically constructing the URI. WebSocket is the same endpoint which is specified in my ad server endpoint in my Pojo. Now line 42 is new WebSocket. We talked about the protocol a little bit. There is also a W3C JavaScript API, which is what you use from a client side to connect to a server side WebSocket endpoint. So essentially, the moment I say new WebSocket here, this is a standard W3C JavaScript API. This is what is establishing a WebSocket connection. This is what is initiating protocol negotiation, a connection handshake between my client and server. Now, this is not a JavaScript that you can polyfill into your browser. Your browser must support this, because what happens is the moment you say new WebSocket, all the connection negotiation, there is a predefined set of headers that need to go, come back, at least for the connection handshake, but that needs to be initiated by the browser. It's a much lower level protocol, so you cannot polyfill it with your own JavaScript. So this must be supported by browser. Now, let me ask, how many of you use Internet Explorer as your primary browser? 1, 2, yeah, well, I can feel company policies here. Well, the reason I ask that is because Chrome, Firefox, Safari, they all support WebSockets very well. IE, if you are using IE, you have to use IE 9, 10 or more. Otherwise, there is no support for WebSocket. That's why I call everything else as modern browser and IE as a legacy browser. Now, once you have WebSocket, and a good website to be aware of in that case is something called as caniuse.com. Well, it's a broader website, first of all. You can go to caniuse.com and you can check for the compatibility of different features like CSS, HTML5. Where are each of these features supported in different browsers? I can specifically go to WebSockets, and here it gives me the history of where WebSockets are supported in which browser. So for example, if I look at here, this is IE, so IE 10 is supported. Up until 9 it wasn't. Firefox and Chrome has been supported for a while, Safari as well. So those are the 3 primary browsers that I typically test on, and they do support WebSockets very well. And then when I show the next sample, I'll also talk about how extensive the Chrome developer tools are, which allows me to debug WebSockets as well pretty easily. Okay. Now, from the JavaScript, I have said new WebSocket. So the way I have lifecycle callback, on message, on error methods, I have the corresponding event handlers on the JavaScript as well. So for example, here I have on open, on message, on error event handlers, and these are my methods over here. So if I look at on open, it's just simple, it's just writing to screen. On message, depending upon whether I'm joining or I'm sending a chat log, I'm updating the relevant field. Okay. And if you see join and send message, the methods are pretty identical. They're just having a different semantics over there. So for example, both of them are using WebSocket.send, and they're both sending text data. Both of them are getting dispatched on the server side to the same message, and then the message is just broadcasting it back to all the clients. Okay, that's just my very simple, trivial WebSocket sample, how you would build a simple chat application. Now, if you are building a Java EE 7 application, then all the Java EE 7 API coordinates are already published in the POM. And that's the API that I'm using really. So JavaX, Java EE API, these coordinates are already published in the Maven Central. You just use that. You of course need JDK 1.7, that's a requirement. And there are the bunch of samples that I have available already, okay? Right, so let's look at our next WebSocket sample then. Now this sample is a collaborative whiteboard built using WebSockets again. But let's run the sample first. Once again, I'm going to use Chrome and Firefox here. So let me open up here as well. And in Chrome, I'm going to also open developer tools. So I can look at my network, refresh the page once more here. And here I can look at, it says WebSockets. So if I click on WebSockets, it's going to show me only WebSocket connection. If I click here, if I specifically look at the headers, now this is where the request was being made, ws:// localhost whiteboard WebSocket. This is the endpoint where it was requesting. This is the key status code that you're looking for. I know it's not really visible, but if you open up Chrome Developer Tools, that's where you can see it. It's saying 101 WebSocket protocol handshake. In this case, here is saying upgrade header, which is really saying upgrading to WebSocket. And here is saying connection upgrade. Those are the two exact headers in exact that shape that needs to go as part of the original connection handshake request from the client to the server. And in the response, you need to get back connection upgrade WebSockets. That's sort of the response, connection handshake response back from the server. So once that is done, everything is then becoming a WebSocket connection. Important part to realize is, once it becomes WebSocket, there is nothing HTTP about it. None of your HTTP semantics work on a WebSocket. Everything like get, put, post, delete, headers, all of those are gone. Everything you have to build as part of your application. Now, when you send a WebSocket message, everything literally goes as a frame. That's sort of the WebSocket terminology here. So I can look at the frames and how the data is being exchanged. Okay. So now let's go to our browser here. This is a collaborative whiteboard. So think about, you're playing it across the internet, multiple browsers, multiple operating systems, even iPads or your mobile phones, and all those would work as well. So here, for example, whatever I click on one browser automatically gets reflected on the other browser. I can change the shape here or a color, and whatever I click around, it automatically gets reflected in the other browser as well. And I can do it both ways, by the way. So if I click here, if I change color here, it gets reflected here too. So it's two-way communication. This is what highlights the fact that even though a server is what is listening to the endpoint, a client is initiating the request, but once client and server are connected, they're both peers. It's a full duplex bidirectional communication channel. Okay. Now, let's say a new player, think about this as a game board. A new player joins the game, and that new player happens to be on a third browser, say Safari. So I'm going to copy the URL here. Copy the URL. Oh, what is this? So now I have a new player that joined the game. Well, all these guys are synced up. So how do I make sure that I send the snapshot of the data to the other browser or to the new player? So all I do is literally click on the button here called as snapshot, and here you can see the data is being reflected. Okay. So what I showed you is a simple game, but let's see the code which is underlying. Okay. By the way, if I click on the WebSocket here, that's sort of a bug in the developer tools. The data does not refresh by itself. But effectively, let's take a look at the data here first. Now, every time I am clicking on the square, or every time I'm clicking in that HTML5 canvas, my coordinates, like X and Y coordinates, my shape and my color, all of that is captured and sent as a JSON structure over the wire. So pure text. So it's sent as a JSON structure, it goes to my backend, which then broadcasts it to all the clients that are listening to it. So that's sort of my text data transfer. Okay. So here you can see, for example, shape square, color red, coordinates X and Y, and so on and so forth. And these are the ones, so these are the ones that are going out from the browser. These are the ones that are coming into the browser. And here, what of course you see is a binary opcode, which is like the snapshot of the data coming in. Let's take a look at the corresponding backing code now. My whiteboard here is very simple. Well, of course, I have a server endpoint with the URI that I'm listening at. Now, I have something called as figure encoder and decoder. As I said, the text data that is coming to me is a JSON structure. So, going by the chat example, I can get the entire JSON structure, suck it up, and then manipulate it, use some JSON processing API, get the values out, and put the values in. But that's too cumbersome, and that's not even dry. It's like I'm going to be repeating that code again and again. That's where WebSocket defines this concept of an encoder and a decoder. What you could do is you could define that instead of playing around with the raw string data, I want to play with my POJOs. On the other hand, define encoders and decoders which actually understands how to take a string data and decode it to a POJO and vice versa. So I'm going to define my encoders and decoders here. So for example, if I look at my decoder here, it says implements decoder.text, and it's going to give me a figure. It's going to decode a string, and it's giving me a figure. And this is exactly where I'm using my JSON processing API, or whatever API you want to use, where you take the string data, convert it into a JSON structure, and return back. The key method here is will decode, wherein you may be getting multiple string data and you may not be ready to decode each and every JSON structure, for example. So will decode will likely peek into the data, a string structure, and make a call. Can I decode this data or not? And then return true or false accordingly. And there are some other lifecycle callback methods as well. Now if I look at my figure encoder, that's again pretty trivial. So encoder.text is going to give me a figure, or actually it operates on figure. So it takes a figure and converts it into a string. So essentially get the JSON, get the string. The advantage of that is my onOpen, onClose stays as is. I have a broadcast figure method. The name of the method doesn't matter. All it matters is the annotation that you put on top of it. So say at on message. Instead of saying string figure, I can actually put figure over here, or my POJO. And then my encoders, decoders will automatically kick in. They will say, oh, I understand string data. I will convert it to it. And then I'm operating directly on my POJOs itself. Another new thing to notice here is, for example, when I'm iterating through peers, my second parameter here is session, which is the client that is sending the request. I don't need to broadcast the data back to the client that is sending the request. So I'm iterating over all the peers, and I'm saying if peer equals session, do not broadcast back to that client. Kind of saves at least basically one less broadcast. Now, broadcast figure is okay. So we understand how my JSON structure, whenever I'm clicking over here, is being broadcast to other clients. So what happens when I'm sending a snapshot? Well, that's a binary data, because effectively I have my HTML5 canvas. From the HTML5 canvas, I'm grabbing the binary data and sending it to the endpoint, which is then sending it all over. So then look at this method, broadcast snapshot. This has a byte buffer. Now this could be a byte array or a byte buffer. And here I'm just getting it as a byte buffer, and literally the implementation is exactly similar. All I'm doing is iterating over peers, making sure it's now the same client, and then broadcasting it to all the endpoints. Let's take a look at my corresponding JavaScript now. Well, figure here is very trivial. In figure, it's just a simple JSON object that is being encapsulated. Similarly, coordinates again is very trivial. So nothing there, X, Y, just getters and setters. start with index.jsp, just an input form, radio buttons for colors, shapes, and then I have my methods here, instant or binary snapshot. All the logic goes really in the JavaScript here. So for example, if I look at my WebSocket.js first, it's still very similar. I'm using WS colon, the WebSocket URI, the endpoint where the WebSocket is listening. I'm doing new WebSocket. Now, by default, if you are sending binary data using WebSocket, it sends using blob as a data format. Now, JavaScript also defines array buffer as a binary type. So you can send data as a binary data using array buffer. So I'm specifically setting the binary type as array buffer. That's a standard WebSocket property that is defined as part of the protocol itself. I have my on message, on error. I have my separate send text and send binary methods here. Now remember, they're both using WebSocket.send. So line 50 and line 55, they're both using WebSocket.send. I just gave them different name to highlight the semantical difference between them. That okay, one is sending a text and one is sending the binary. But otherwise, the syntax is exactly the same. In here, I have just on message, which is my on message event handler. If I receive the data, I know if it's string, then I have to just redraw the text. And if it's binary, then I need to draw the binary image. Over here, it's just my simple manipulation of the HTML5 canvas. I'm defining the image. I'm grabbing my, I'm checking for my radio buttons. This is where I'm JSONifying my shape, color, and X and Y coordinates. And then I define my image binary here. I draw my image text and draw my image binary. That's about it. Any questions so far on WebSockets in general?
Is it SSL?
Is it SSL? Yes. So in this case, I'm using WS colon, which does the connection negotiation over HTTP. If you want to do over SSL, then you can do WSS, which works over HTTPS. Another thing that the JSR 356 defines is where the browser behaviors are still a little different in terms of when an authentication request would pop up. So the way when the JSR itself was final like 3 months ago, or at least had to be frozen 6 months ago. But so at that time, the decision was made that if you want to use some sort of authentication, either you use WSS or you make sure that the HTTP connection that you're connecting with, you do some sort of a form-based authentication or a token-based authentication on the HTTP, and then you start your WS connection on that. So use a prior authentication on HTTP and then say, okay, I'm going to do WS colon on that. Now, I showed you the example where you can create a WebSocket endpoint using annotation. JSR 356 also allows you to do programmatic endpoint, which gives you a little bit more control over how you define your endpoint. So if I look at this over here, well, let's look at the source code first. I don't have any annotation on this Pojo over here. So I'm saying public class my endpoint is extending endpoint interface. Okay. So if I do endpoint interface, in NetBeans IDE, of course, you see all your Java E7, Java docs, everything integrated in there. So it's a public abstract class endpoint. Okay. Now the endpoint gives me an abstract method called as onOpen. So essentially, whenever a connection to this endpoint is being opened, you override that method. Okay, and that's where pretty much most of my logic goes. I have on close, on error, my lifecycle callback handlers. But in on open, basically, you explicitly add your message handlers. Okay, I want to add a message handler. I can either get the entire message, or maybe somebody is streaming from the other side, I'm getting partial messages. So those different design patterns are possible. So the point that I want to highlight here is that the basic programming model works using annotations, but a lot more powerful programming model is available if you are using this programmatic endpoint. So here you can say, you can set up your message handlers, you can set up for string or binary, whatever you care about. In this case, I'm setting for string. So I have a at on message or on message method, not add on message. Now in this case, I'm building my request response design pattern. In the sense, in case of WebSocket, a client sends a request, a client sends a request, a client sends a request. Server may not respond back. Server may send a request back or send a message back from server to the client. So in this case, I'm just building a request design response design pattern in the sense, every request that comes in, I'm going to add a message handler, and on the message handler, I have at on message. The payload that comes as part of the request is mapped to this parameter over here. Then of course I have encapsulation of session. This is the client that is sending the request. On the client, I say, give me the remote, that means the other endpoint, and then to the remote endpoint, send the response back. In this case, I'm just literally echoing the response back, but you can build a little bit more elaborate system if you want to. Now this is a message handler whole on text. Similarly, I can do a message handler on a binary. Now text and binary are two method types. The third one, of course, is a pong message, which is defined as part of the WebSocket protocol, which is essentially called as ping pong messages, which is what you use to keep your heartbeat alive. So there's support for that as well. All right, I'm going to move on to the next technology now. So let's take a look at batch. Now, batch processing, we all know what batch processing really means. Spring Batch has been really successful for a long time, but then you have to bundle it as part of your application. Class loading, the war file size, all those issues come along with it. So now, as part of Java EE 7, batch processing is integrated as part of the platform itself. There are two processing styles for batch. One is called as chunk processing style, and the other one is called as batchlet. In chunk processing style, which is the primary processing style, there is a concept of a item reader, item processor, and item writer. As I said, that's the primary processing style. So what you do over there is you read an item, you pass it on to the processor, which processes the item. Processing could be validating the data, or checking with something else, or cleaning up the data, or massaging the data, and then it gives it to the item writer for aggregation. So you read, process, aggregate, add writer. Read, process, aggregate, add writer, and you define what is your chunk size for that transaction. Once the chunk size is reached, the writer writes the data out. The read, process, write, all of that together inherently is done within a transaction. And there is an inherent checkpointing mechanism as well that is available to you. So that is the primary processing style. And then the other processing style that we talked about is batchlet, where you can roll your own processing style. Effectively, the chunk processing style is item-oriented processing style. The batchlet is a task-oriented processing style. So you can use either of those, but chunk is the preferred one. So let's take a look at the chunk processing style first. First of all, now the entry point to a batch job in Java EE7 is a job XML or a job specification language, which is defined as XML, and that's why it's called as job XML. The location where this job XML needs to live is predefined by the specification. It has to be in meta-inf/batch-jobs, and that's where I'm bundling this particular job XML. The name doesn't matter, you can call it whatever name, but the name is relevant, and I'll explain that in a second. Now in my job XML here, I have a job. It's in a predefined namespace. Each job can have multiple steps. So I could have 1 step, 2 step, 3 step, and we can define a flow. We'll talk about the flow a little bit later. In this case, this is a trivial job, just 1 step. Each step is of the type chunk or batch ret. In this case, is chunk. By default, the chunk size is defined to be 10. That means you will read, process, do that 10 times, and the aggregation will happen. And when the 10 items have been read and processed, all the 10 items together, depending upon how many have been processed correctly, will be written out. I'm overriding the value over here, saying item count is 3. The reader, processor, and writer are defined in my XML file over here. These are essentially my CDI names, or the CDI name of the beans that are packaged as part of my application. So let's take a look at my item reader, processor, and writer. Now my item reader here, it extends abstract item reader. I have an open method here. This open method is where you will typically initialize your streams, either your streams or your database connections. I just happen to use a simple string tokenizer. It's easy and efficient to show a simple sample. But this is exactly where you'll open your streams. Then I have a read item method, which returns an input record. In this case, it's a simple POJO. So if I look at my input record here, it's just a POJO with a private field with getter and setter over here. Okay, nothing fancy. Now in read item, I am effectively just reading the item. I'm not processing it in any sense. It's just blindly reading one record and returning it back. That's it. Now once I'm done reading all the records, let's say I've read all the records and there are no more records to be read, then I return null. So that is essentially the beginning of the end of the entire batch processing. Because the moment you say return null, that means it's going to go to processing, and then it will look at the item count, then it will write it out, and that will effectively terminate the entire batch job. But you can either return an input record or you can return null here. My item processor is again a very trivial class. It just implements item processor here. Whatever input record you read in the item reader is automatically passed over to the item processor over here as an object. In here is where you actually process the item. In this case, my processing logic is pretty trivial. All I'm looking for is if it's an even number record, because in my reader, when I'm doing a string tokenizer, it's 1 to 10. I'm just getting one token at a time and initializing my input record. In my processor, I'm saying, okay, if the record is even number, then dump it. If it's odd number, take it and double it up by 2 and create a new output record. Now, my output record class here is again very trivial, very similar. But this is to highlight the fact that your input record and output record could be completely separate or could be completely unrelated. But this is where you return an output record. And finally, you have an item writer. In item writer here, again, it also has an open method. I'm not really using it, but that's where you'll initialize your database connection, streams, etc. And the primary thing over here is the write items method, which has a list, which is where the aggregation automatically happens, and then it writes it out. Now think about the use case where you have to read a CSV file So it's a comma-separated value file. You're reading it from a file input stream. You read one line at a time in the reader. So you literally just read the line and return it to the processor. The processor is going to validate the field and potentially convert it into a JPA entity. Or if the record is not right, so for example, if I go back to processor here, let's say if the record is not right, it does not meet the validation criteria, you can return null. That means that item will not be processed. So the number of items read and processed and aggregated, they may be different. But in item writer effectively is where you write all the items out to the stream. So this is where all my checkpointing is automatically done. Read, process, write, checkpointing being done, all done within a transaction. So the idea is, let's say if you're reading 100,000 records, if you've read 50,000 and your item count is say 1,000, somewhere after 50,000 record, say 50,200 record is where you fail. That doesn't mean you have to go all the way back to 0 and then read all the records again. So you can literally resume your processing of the job from 50,000 records. Now, I've shown you how my reader, processor, and writer are figured out. How do I trigger my job? There's a lot of metadata that is in this servlet. So I'm going to trigger the job from a servlet, for example. But look at the code that is highlighted for you. So for example, here I'm saying batch runtime. Batch runtime is a standard class from JavaX batch package. Batch runtime, give me a job operator. To the job operator. Now remember, my XML file name here, as I was saying earlier, is relevant. myjob.xml. So to the job operator, I say my job, and I can pass it a set of properties. And that's how I trigger my job. And then subsequently, I get some other metadata about the job. What time was the job created? What time the job started? What are the different job names? And all that stuff very easily. Now, if a job is not successful, or if a job is stopped in between, or if a job failed for some reason, all of those statuses can be very easily checked. GlassFish comes with a web-based administration console. In the administration console, you can look at the jobs that are currently running. It will report the status of it for you. And then you can either restart the job or terminate the job, and all those things are possible. Not only just the web-based administration console, because that's more graphical, you have to click on it, but it also comes with a REST backend. So where you can write scripts to issue curl commands. Give me the status, and if the status is this, then do this, and things like that. So that's very powerful as well. So web-based administration console, REST backend, and then we have a command line interface, which is ASAdmin. So all of those, they allow you to manipulate the status of your jobs very easily. Any questions so far on batch?
So where in the processing would you be able to keep like a running total or averages or something over, let's say if you're doing like a concept values file and you're going over line over line over line. Is it in the process object that you keep like running totals or something like that?
Well, if you want to do a running total, this is more like a writer, I think so.
It would be in the writer?
Yeah, because
so there's persistence in the writer, even if you just call it over and over and over.
Right. So now the idea is you read a record in the reader, so you're not doing it over there for sure. Processor is only for processing one item, unless you create your own static variables and you keep a running total over there. But from processor again, once you process it, you can return null or you can return a valid object. Now the idea is in the writer is where you have all the objects that are valid available to you. So either you can iterate over there, or processor would be a fine place too, I think so.
Can you define some of these processing jobs hierarchically?
Yes, I'll talk about that next. Yeah. The question was, can we assign some hierarchy to the processing jobs? Okay, let's take a look at that. the readers, processors, and writers, they sort of become sort of an implementation detail. The fun stuff really happens in the job XML. So what I'll be doing is for batch, and I'm going to be showing you different job XMLs and how these jobs can be arranged. So here, for example, I have a job. The job has 2 steps. I'm defining a step here. Say step ID equals step 1. This step is a chunk. Again, item count is 3, reader, processor, writer. And then I'm defining a flow of the job. That after step 1 is done, my next is step 2. So if I am defining multiple steps, I can define a flow. After step 1, go to step 2 and step 3 and so on and so forth. So that's one way of looking at it, how you can create a flow. Now, this is a little bit more elaborate. They allow you to create sort of a workflow as well within the jobs. So for example, here I'm saying this is a step. This is a step 1. I'm referring to a batchlet over here. It's not a chunk instead. And I'm saying the next one is a decider. Now, decider is where I decide which step would be executed next. It's not really the step by itself, but effectively decider is saying decider 1. It's saying ID is decider 1. Decider 1 goes over here. It's referencing to my decider. Now my decider, if we take a look at the source code here in this case, so here is my decider. Now it's giving me a bunch of step executions, basically the steps that are available at this point of time. And I'm just printing out their status over here, and I'm returning a specific status. So let's say I decide based upon the step execution that, oh, this step execution is going well, and I want to return with this status. In this case, I'm returning foo bar. And here I have different statuses. Like if you're returning foo bar, then you go to step 3. I could have said if you fail on foo bar, then the exit status on foo bar 2. So you can get very elaborate in terms of, if I get one status, should I go to the next job, or should I just change the status? Now remember, for any batch job, there is a terminated status. That means the job is terminated or the job is completed. These could be completely different. Terminated could be in between, and the job completed means job is over. That means all the processing is done. So it could have different statuses. I could even say, for example, if the exit status is foo bar 3, then restart step 3. If I go to restart step 3 is again a batchlet. I haven't shown an example of a batchlet, so let me show that here as well.
Is the exit status defined in the decider class?
Right. Yeah, so that's what I thought I showed that. So here in my decider, for example, this is my implementation specific exit status. So
That is the exit status.
So yeah, when I return back here from the decide, that is the exit status. So here I could have returned multiple exit statuses.
Right. I thought that was the on. On foo bar.
Right. So it says on exit status foo bar, go to step 3 basically.
Okay. So I'm just confused about the next stop. On foo bar 2, exit status foo bar 2.
Right. Well, this is not actually implemented in the decider. So effectively from the decider here, and maybe I was experimenting with it, I didn't comment it, but effectively here I could return multiple exit status. I could say return foo bar. So for example, I'm going through the step execution over here. In one case I might have returned foo bar, in the other case I might have returned foo bar 2. So in that case my decider block here becomes relevant. So if it's foo bar, I'm saying go to step 3. If the exit status is foo bar 2, then change the exit status to foo bar 3 and restart step 3.
Oh, I see. You're defining the exit status of foo bar 3. You're
Right.
testing.
Right. Now, as I said, batchlet is a task-oriented processing. So here, all I'm saying is extends abstract batchlet. I just have a simple method called as process. And in that process, you can do whatever you want to do. One-time file upload, send an email, or things like that. But this is literally just one time. Now, one of the questions people typically ask around batch processing is, how do I schedule my jobs? Well, so there is no specific scheduling mechanisms in the batch processing itself, but you can definitely use EJBs. For example, if you have Enterprise Java Beans as part of your application, then within an Enterprise Java Bean, you can have any public method annotated with @schedule annotation. Using @schedule, you can specify cron-like syntax and say, I'm going to trigger this method at such and such cron time. And then the method would automatically trigger, and then you can start your batch job, and that will basically schedule your batch job effectively at that very time. Here is another example that shows you. So let's say if there are exceptions that are being thrown either during your reader or processor or writer, if an exception is thrown, then the job is automatically stopped by default. If you want to handle them, let's say while you're reading a CSV record or you're validating the record, there's a number format exception. And it says, you know what, never mind, ignore the record, just keep going on with the processing. Or ignore the record if there are 5 such errors, but for the 6th error, stop the processing. You want to do something like that. So there are provisions to do that in the job XML. So here, I'm saying, well, first of all, I'm defining my listeners also here. I can do before step, after step, all those listeners are possible. So I can trigger my methods. That's one part that I'm highlighting here. The other part is about the exceptions here. So I'm saying skippable exception classes. So I'm saying if it's a runtime exception, then include it. That means skip it. But if it's an IO exception, so for example, you're not even able to find your file from which you need to read the CSV data, that's not a skippable exception. You're saying exclude that. So you can define the different exceptions that you want to include or exclude as part of the skipping process. That's not the one, different one. Here is another interesting design pattern. So let's say you're running your batch processing job on a multi-core machine. You can definitely leverage all of your processors very easily in that case. So let's say you're processing, say, 100,000 records, and you want to split up your readers, processors, and writers among different records. So here what I'm doing is, I have still item count as 3, but I have an item reader where I'm giving a start and an end property. So effectively, I'm taking my chunk and I'm splitting it into multiple partitions. How do I define my partitions? First of all, let's say I'm running it on a 2-core machine. Then I'm saying, okay, I have a partition. The plan says run it on 2 partitions. There's a partition 0 and a partition 1. Partition 0 has value of 1 and 10, which is start and end. Partition 1 says start value is 11, end value is 20. And then I'm specifying the value of partition plan start and end over here. So effectively, what's happening is I have 2 core machine over here. In each processor, I'm running these jobs parallelly. I'm passing the properties. Those properties are then read by my item reader. It says where to start and where to end. So those 2 readers are doing the job parallelly. Let's see how my reader actually modified to handle those additional properties. All I need to do is I need to inject my batch property here. See, the value is start and the value is end. And when I'm actually opening up, I need to specify my start and end, and I'm just building up my tokenizer here accordingly. But the idea is you have the start and end value in your open method, and then you know exactly where you need to read it from. My read item, I could either alter my open method or I could either alter my read item method. I just altered my open method for convenience over here, but I would see that you would be altering more of your read item method. That read from this up until this. If you're exceeding the limit, don't read that particular item. But the idea is you could have your read item running in parallel across 2 different cores over here. Okay, any questions on batch?
So there's a GUI admin console.
Yeah, let's take a look.
It's, I was going to ask, there's not anything for graphically designing these config files, right? It has to be done just straight up XML.
That's correct. Yeah, the GUI admin console. Well, let's look at that. Now this is definitely GlassFish specific. So GlassFish is a runtime server, and it comes with the administration console where you can do all of your administration of your Java EE environment. So it has a tab which says this is where my batch jobs are going to be visible. So if I look at my server here, I think, and I look at my batch tab here, I haven't run any jobs here, but otherwise this is where you would see what is the execution ID, job name, batch status, exit status, so on and so forth. Now the tool itself does not give any provisions to restart, stop the jobs. Those still need to be done programmatically, but you can monitor all the status over here itself. And similarly, I have the command line interface, which is AS admin, where I can issue commands to monitor the status of the jobs exactly. There are APIs in the JavaX batch package, which allows you to restart, stop, resume the jobs depending upon a particular ID.
What's the configuration tab show?
Let's take a look. We'll find out. Yeah, this is the executor service lookup. So we are using a managed executor service. I think it's using a default managed executor service. We'll talk about the default executor service, but you may be able to create your own executor service, and then you can accordingly point to it. Now, everything that you do, one of the core concepts of batch processing is there is a job repository where all the jobs are stored, the checkpointing, etc. All of that is done in a database. It's required for a Java EE7 runtime environment to provision a database. GlassFish comes bundled with JavaDB, and so that's where all the information is stored automatically for you. So, and this is what the data source lookup is defining. This is again, a default name that comes as part of GlassFish. You may be able to reconfigure this, point it to this particular database instead. All right, so let's take a look at the next technology now. I can't close all my projects. Okay. So the next technology that we will take a look at is JSON processing. Now, JSON is definitely the lingua franca of the web. Whether you're doing on the server side or on the client side, is sort of the default data format that everybody is using. Now, typically you bundle your own third-party library, adding to the size of the WAR file, compatibility and all those issues. So keeping that into consideration, we have added first-class support for JSON processing in the Java platform itself. If I give you an analogy from the XML land, for example, in XML land, we have JAX-P, or Java API for XML processing, and JAX-B, which is Java API for XML binding. In JAX-P, you have a streaming API and a DOM API, which are lower level APIs. JAX-B says, take a POJO, put annotation on it, and go figure, map it to a XML land. The Java API for JSON processing is similar to JAX-P at this time. There is no data binding API where you can take a POJO and put annotation and say, go map it to a JSON right now. That's coming up in the next release, and we've already started working on that. So hopefully the JSR will be filed soon, and you will start seeing some results on that. But up until then, the Java API for JSON processing gives you two levels of API. The one of them is a streaming API, and the other is a DOM API. Streaming API is a lower level API wherein if you're reading a JSON structure, it spits out events. Events like, think about JSON structure. JSON is basically a name value pair. So the kind of events that it generates is, start of a name, start of a value. The value could be an array, so start of an array, end of an array, so on and so forth. So it generates all those events. It reads, it parses through the element, generates those events. If you are interested in a particular event, you say, okay, I'm interested in that event. And then you say, now you go parse the value. So it does not parse the value until you explicitly ask for. The DOM API, on the other hand, reads the entire object in the memory and then gives you the flexibility of indexing into your document. I want this element, so give me now. Give me this element now. And then there is no additional parsing to be done. So there are pros and cons of using each and every one, but just to kind of help you understand on how the whole thing is structured. So let me show you object reader first, which is where I'm going to use a DOM API to read an object. Okay. Now the first thing that I do is I create a reader. The reader could be done from I create a reader. I'm just doing it from a convenience string reader here, and then I read the object. So this is, in this case, is going to be a completely empty object. This is my JSON object effectively that I'm reading. Okay, I say read object, I get a JSON object, and I can print it to the stream. Then I'm reading an object with two elements here. So apple red, banana yellow. So I read an object with two elements, and then again I print it out over there. Now the advantage over here is, once I get my JSON, then I can use a standard API, say JSON.getString apple, getString banana. So I can get their values, using getter methods. I can create the same object with an array with two objects, so that can be done too. I can read a nested structure as well. Okay, so let's run this. I got to run from here. So I'm gonna use a reader to begin with, and I'm reading an empty object, comes out like this. I'm reading an object with two elements, reading an array with two objects, and reading a nested structure. So all kind of complex or simple structures can be very easily dealt with using the DOM API. I've done this with reader, but I can of course do this with stream as well. Similar output, but if I have to show you the code back here, So in this case, I'm reading it from a stream. So I have 1.json. So let's look at my 1.json. Oh, where is it? So this is my 1.json. I'm just reading this as a stream and displaying the value. This is my 2.json. I just read it as a stream. If I look at my source code back, so once again, servlet context get resource as stream /2.json /3.json /4.json, and I just print out the value. So if I look at my 3.json here, it's again the same structure, and then I have a 4.json. So this is sort of my reading using a DOM API. I can build an object very easily as well. So I say JSON.create object builder. I build an empty object. So this is a completely empty object in this case. I want to build a little bit more elaborate object with two elements over there. So apple red, banana yellow. So I say create object builder. There I say add name, value, and I build the object. And then I write it out. Now I want to build an array. So I say create array builder. Then in an array, I'm going to add two elements over here. So JSON create object builder, add name value, and build it. And so on and so forth. You can build your objects over here. If I were to run it, I say generate JSON using DOM. Oh, it's not printing my DOM structures. I don't know why is it not printing my DOM structures here. I don't know why is it not printing my DOM structures. But you get the point. So that's my DOM API. Then similarly, I have a streaming API. So let's look at my streaming parser, for example. I don't think I was sending it to system.out. So I'll look that because you said it, but well, if it's system.out, then we should be seeing something here. Nope, nothing here. Nothing here. Let's try one more time here. So no. Oh, actually it is system.out. Create writer system.out. And why is it not writing out to system.out? No, nothing here. This is reader. This is builder. It should have written something here. Yeah. Well, I'll take a look. So let's take a look at our streaming API now. Now in streaming API, well, let's look from the stream perspective instead of a reader. JSON parser from stream. Now remember, we can read the data either using a reader or a stream. I'm just using the stream because I can show you the corresponding JSON data very conveniently. So once again, the same 1.json, 2.json, 3, 4.json. From the JSON, I create a parser. I get a parser, and then I have this parse events that the method that I have written by myself. All I'm doing is I'm parsing through all the events that is generating. Typically, you will not be looking at all the events that are being generated. I'm just looking at so that I can print it out accordingly. But these are the events that are essentially generated. Start array, start object, end array, and a whole bunch of others. Okay. So if I run this, well, you have seen 1.json empty, 2.json just a couple of name values, array with 2 elements and a little bit more nested structure. Now if I run this particular project, and so if I'm reading an empty object, that is printing out what events are being spit up. So starting an object, ending an object. Then it says starting an, so go back here. So in 1.json is starting an object, and this is ending an object. Actually, starting an object here, ending an object right here. Now here in this case, reading an object with 2 elements. So this is my 2.json. So this is starting an object. That's where this event is being spit out. Found key, apple. So this is where my found key event is being spit up. This is found value, red. So this is where my found value is being spit out. Again, found another key, banana, found value yellow, and ending an object. So this is my ending an object. If I look at my little bit more elaborate structure here, so writing a nested structure here, which is 4.json. So this is start of an object, start of a key, or actually key, value, once again a key. The value could of course be a number. This is a key, this is a start of an array, and each element of the array. So for example here, starting an array, found value, 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 you found 3 values, then you end an array and you end an object. So you see, there is complete DOM API or the object model API and a streaming API support for JSON processing in Java EE 7. And I will show you a little bit more elaborate sample on how I can use this to create my custom readers and writers when we take a look at JAX RS, for example. Any questions on JSON processing? Just like JAXP, there is an API and an implementation as well. So yeah, so if I look at, and all the APIs that I was using, for example, so if I open any of the projects, for example, let's say object reader, and then in object reader, I look at the source packages. So here there are JavaX JSON APIs that I was using. No, there are no factories in here. One of the things that we have also talked about is how we can simplify this using CDI, but that's not final. But this is sort of the first version of the API. Now, typically, what you can do is you can look at the EE7 Java EE7 Java docs. This is the local version here. But let's Google it. Java EE7 Java docs. Okay, shows up at the top. So if I look at JSON API, for example, then you can look at all the JSON API here. There's a factory pattern, but that is typically required if you want to configure your parsers in a specific way. But the more common design pattern is where you can just say, use a default parser. And that, good point actually, that mechanism allows you to plug in your custom parsers as well, the factory mechanism. So here, for example, I have a JSON array builder or JSON array builder factory, and I can, in the factory, for example, is it the factory? Yeah. I think either using configuration or when you are doing create array builder, somewhere you can plug in your own parsers.
Do you have any idea when that third way of just using annotations and like JAX-Bs?
Yeah. The Java API for JSON binding is the one that we are working on right now. Now, if you need some support for that, there is some support for that already available in GlassFish. It's not a standard support. So for example, Eclipse Link has this project called as Moxie. And Moxie allows you to do data binding already. If I were to say Eclipse Link Moxie. So if I go here, it does allow XML binding with JAX-B and SDO, and it also gives you that for JSON as well. So that is something that you can look at. And this is the team that is actually working on the JSR as well. So the APIs may look familiar or similar to some extent, but that's completely up to the expert group effectively. No timelines yet, though. Yeah, that's your question was, sir. Okay, let's keep going then. Okay, we have about 10 minutes, so I'll cover a lighter technology for now. Then after the break, I'll cover technologies that are going to take a little bit longer. Now in JPA or Java Persistence API, that's the standard way of doing object relational mapping. It says, okay, you have a database table, how you can map a database table to a JPA entity, defines an API on how you can manipulate those entities on the database, entity manager, persistence context, all that. That's being defined part of the JPA itself. But that was like from database to entity. There was no way by which you can say, oh, take an entity and generate database out of it, or generate my scripts out of it. That was not possible, at least in a standard JPA way. Now JPA comes with this pluggable persistence provider mechanism, wherein the API is there, but the persistence provider could be Hibernate, Eclipse Link, or whatever you care about. So all of those are different persistence providers. Each of those persistence providers were offering mechanism to map API, to map POJO into a database, but not a standard. JPA defines that. Well, that's one part of it. The second part of it is we're also introducing new schema generation properties. For example, in the persistence.xml, you can define Java x.persistence.schema generation properties. So let me walk you through them. So for example, in this case, I'm saying Java X persistence schema generation. These are new set of properties that have been introduced in JPA 2.1, part of Java E7. I'm saying the database action is drop and create. That means whatever database is there, drop it and create it. Well, on what basis? So then it's saying the create source is going to be metadata. Metadata being, you take a look at the JPA entity, based upon that, you generate the database tables. I can delete this value and I can show you the values that are available here. Hello, show me. Right now it's just showing metadata, but this could also be metadata and script. So for example, you can provide your custom DDL scripts or data definition language, which you can plug in saying, take a look at those scripts. Don't care about what you have. Use those scripts to generate the table definition. So I'll show you a sample of that also.
Are those scripts part of the spec as well?
Of the
How those scripts are written, is that part of the spec?
so let me no, the scripts are of course all your own.
Okay.
But let me show you a sample of that. So here, for example, I have schema generation database action is still drop and create. The create source in this case is not metadata. The create source is script. That means look at the scripts and based upon that create table definition. And even for dropping, I'm saying the value is script. That means even for dropping, look at the scripts. And then I need to specify what my script, create script sources and drop script sources. Those scripts are standard SQL scripts. There's nothing fancy about them. So you can either bundle them as part of your application, wherever you want to bundle them, make sure they're accessible to your persistence provider, or it could be a URI sitting somewhere outside your application. So in this case, my create and drop scripts are bundled in the meta-inf directory. And then there is a new property as well, which is not schema generation, but this is loading the data. So we talked about DDL. Now we have a DML, or data manipulation language, by which I can load the data. All these three scripts for me are bundled in the application. So for example, I have a create.sql, just a simple create table, employee, whatever you want to do that. A simple drop table, employee, whatever you want to do, and a simple load. So just a whole bunch of employees over here. So if I run it here, now, well, one more thing to highlight here is any thoughts on what else is missing from this persistence.xml? Well, the data source itself is not specified, not the upgrade really, but the data source is missing. I have not specified a data source in this persistence.xml. That's again a new feature of Java EE 7, where we have defined a default data source. And the idea is that if you are building a Java EE application, you are very likely to build a database-driven application. If you're building a database-driven application, why do you have to create a data source? Let's provide a default data source for you just to get you started. And then the JPA specification says if there is no JTA data source, which is how you specify your JTA or data source in the persistence.xml, it says if there is no JTA data source, then fall back on the default data source. So by not specifying the default data source, I'm going back to the default data source. And the advantage, once again, nothing GlassFish specific, but this is a pure Java EE 7 application. You take this application on any Java EE 7 compliant container, it will just run fine out of the box, because it will go back to the default data source, it will use the bundled scripts, all of that will just trigger in automatically. So if I run this application here, it says basically if you see this page, that means data tables are created using JPA 2.1 standard properties, and it even gives me the database URL. If I say list employees, and gives me a whole bunch of employees from the Big Bang Theory. And the way we verify this is if I go to my databases and I say connect to my default database, and there I say show me the tables, and here is my employee schema gen scripts. Now I can right click here and I can say get rid of this, I don't want this table anymore, and if I run the project again, the table will be automatically created for me, although the application deployment would have automatically dropped and recreated the table for me as well. So once again, list employees, and the list is back again. And if I go back to my services here, I refresh the list of tables, the table is back here.
I'm assuming that the spec provides for you to set up the implementation aliases or user IDs and passwords such that if your DBA group maintains tight control over the database as opposed to your operations group installing these apps.
Yeah.
Separate those.
Right. It allows you to specify username and passwords. Well, the username and password. Okay, two things. First of all, if you are, this is primarily a development time thing. Okay, in the sense you are a JPA expert. You know exactly how to define your entity. You created your entity, and then you can say, oh, you know what? Don't generate the database itself. Just generate the scripts for me. Show me what the scripts will look like. Then you hand over those scripts to your DBA, who then fine tunes the script give it back to you, and then you use them in a development purpose. So that's a sort of an iterative process, go back and forth, go back and forth. And then eventually, you don't want to create your database, production database using these scripts. No, like, hey, I've deployed my application, delete everything, and start the database all over again. So it's more like kind of helping you become friends with your DBA, which generally says, no, you stay back, I stay back, it's my on my territory. So this certainly enables that.
Is there a tag or an attribute that tells the script not to run, or how do you separate to prevent it from running in production?
What do you mean?
How does it know not to run those scripts or whatever?
Well, yeah. So here, for example, let's say you have specified all the properties, and that's why I was hoping it will show me something here. Instead of saying drop and create, I can just change the value to none. So it would not do anything. So
transform your persistence XML between environments then.
oh, I see. Yeah.
Like a scope.
Yeah. Right. Well, other than that, JPA also provides support for stored procedures. So there is a stored procedure annotation by which you can tag into your database saying, okay, just like named queries, you can say, here's a stored procedure, so I want to look at the stored procedure and execute it. That's possible as well. The criteria query API that we talked about, in JPA 2, it was primarily for reading. Now you can actually do updates and deletes with the criteria query API, it's type safe API. What else? Sort of the major features for JPA. So I think we are officially at break now, and we'll resume back at 11 o'clock. Thank you.